this video, what we are going to do is we are going to do some scenario related questions. Instead of they are giving us the truth table, we are going to come up with the truth table also given on the scenario given to us. Okay, so look at the first question. A security alarm system is installed in a building to detect intrusions. The system uses three senses. Yeah, the system uses three senses. So they are given as A, B, and C, each of which can detect motion and provide a logical input to the circuit, and the input is either 0, no motion detected, or 1, motion is detected. Okay, so first of all, this is the main thing that you have to keep in mind. You have to look at the 0, what 0 means and what 1 means. Okay, sometimes they may give in opposite way. Okay, they may say 1 input is 1 if no motion is detected, and 0 if motion is not detected. So you have to be careful about that. But here it's straightforward: no motion 0, motion 1. The alarm is triggered, output is equals to 1 if at least two sensors detect motion simultaneously. Okay, indicating a high likelihood of an intrusion. Otherwise, the alarm remains off, output 0. So this is what they are saying. Okay, so we are going to now do this question. Okay, first of all, let's draw the truth table. So let's say we have three sensors here. We have the A, B, C sensors. Okay, and we have the output Z. Okay, so first of all, let's write down all the combinations possible. Okay, so can you remember the question? Okay, the question, they have clearly stated that at least if at least two sensors are on, the output will be 1. Okay, if two sensors are detecting motion, okay, which means two sensors are 1, the output will be also 1. Okay, if you say in this specific combination 0 0 0, all are 0, so the output will also be 0. Here if you see, there is only one output, right? There is only one output. I mean, there is only one. There is only one sensor that has detected there is a motion. So this will also be 0. Similarly, here also we will have 0, but here we will have 1. Why? There are two sensors detecting motion. And here, what about here? Well, we don't have to mention that. Why? Only one sensor is detecting. Other three combinations, okay, other three instances, the output will be 1. Okay, why? Here two sensors are reading, here two sensors are reading, here all three sensors are reading. In the question, they have clearly said at least two sensors. If at least two sensors read on, okay, the motion is recorded, okay, well then the output will be 1. That's the idea behind this. Okay, now we can write down the min terms first. So this is a min term A bar B C. This is a min term A B bar C. This is another min term A B C bar, and this is another min term A B C. Okay, so what is the expression? Well, we can give z is equals to, okay, a bar bc plus a b bar c plus a b c bar plus a b c. Okay, now what should we do? Well, now we can try and simplify. Yeah, now we can try and simplify. That's all we have to do. So let's look at this. What do we have? So here we have a b. Here we have a b. So I can simplify that. So a bar b c plus a b bar c plus, if I take a b as the common factor, c plus c bar will be given. So according to the inverse law, c plus c bar is equals to 1. Okay, so this is a b directly. Okay, so we have a bar bc plus a b bar c plus ab. Okay, now what can I do? Well, I can take a as the common factor, so that will give me a bar bc plus a into, I'll write this one first, so it will be b plus b bar c. Okay, so that will give us a bar bc plus a into b plus c. Why? According to the redundancy law. Now what I can do is, it will be a bar bc plus ab plus ac. Okay, so what can I do here? Well, I can take b as the common factor in these two terms. Okay, I can take b as a common factor, or I can take c as a common factor. It doesn't matter. So let's take b as a common factor. So that will give me, I'm writing this one first, a plus a bar b plus ac. So again, it's the same thing according to redundancy law. You'll get b into a plus b plus ac. So the final answer will be ab. Well, this is a c, right? Yeah, I should have it. Yeah, that's fine. So let's write c here. A plus a bar c here also C. So the output will be AB plus BC plus AC. Okay, now we can draw the circuit diagram. Okay, now we can draw the circuit diagram. So the output is given as Z equals to AB plus BC plus AC. So let me draw a whiteboard first. So first of all, we need the signal lines A, B, and then C. Okay, let me draw the signal lines first. This is the signal line B, this is the signal line C, and finally this is the signal line A. Now we can have A and B connected using an AND gate. A and B connected using an AND gate. Now B and C in an AND gate. So B is there, B is there, and then we have A and C. So we connect A and C to the AND gate. There is another AND gate, and finally we have to pass them through a single OR gate. We have to pass them through a single OR gate. So now you can see the output is perfect. Why? Here we have A, here we have B, and the output will be A dot B, and here we have B, and then C, the output will be B dot C. Here we have A, here we have C, so the output will be A dot C. When we pass it through an OR gate, the output can be found out by AB plus BC plus AC. Okay, we can simplify further. If you find this specific sum of products form, okay, of expression, you can simplify further. You can directly write this down. This is something that we normally use. Okay, so this is all you have to do this question. Okay, so it's pretty simple. Find the truth table. Okay, then write the expression. Then you can draw the, simplify and draw the circuit. Now let's do this question. A water purification system has three sensors A, B, and C, each monitoring a specific parameter, example pH level or some examples. We don't have to care about that. The system is designed to activate an alert signals output equals to 1 if exactly two sensors detect abnormal conditions simultaneously. Okay, so exactly two sensors. We can't have all the sensors working. No, we can only have only two sensors working. Okay, if fewer than two or all three sensors detect abnormalities, the alert signal remains off. Okay, so that's what we are going to do. So let's first of all draw the truth table. I'll meet you after drawing the truth table. Now let's fill the truth table for the output. Okay, let's say the output is Z. So they have clearly said us at least, exactly two, sorry, not at least, exactly two sensors should read the abnormality, which means one. They should be one. So here if you see there is no abnormalities. So the output is 0. Here only one abnormality, so 0. Here also the same. Exactly two abnormalities are found, so the output will be 1. Okay, and here only one abnormality, so 0. Here we have two ones, so output will be 1. Here we have two ones, so the output will be 1. Here all three are working, therefore the output will be 0 because they have clearly stated that that is not the case. Okay, you can't actually use that as the min term. Okay, so they have clearly stated that. So now let's come up with the min terms. So this is a min term. Okay, so that is A, B bar, C bar, and this is another min term which is A, B bar, C, and finally, wait. Here we have A, B, C bar, right? A bar, B, C. Yeah, this is A bar, B, C. This is A, B bar, C, and finally A, B, C bar. C. Cool. Now, what should we do? That's the question. So how can we do this? Well, let's write down the expression. So expression will be A bar BC plus A B bar C plus A B C bar. Okay. If you look at this specific one, okay, if you look at this specific expression, we can't actually simplify this. Okay, we can't actually simplify this. It may look like maybe it's possible, but it is not. Okay, let's say you're taking C as common from these two variables. Well, then you will get C into A bar B plus A B bar. Okay, and then plus A B C bar. Okay, but then you can't do anything here, right? After this, you can't do anything here. Not possible. Okay, it's not possible. Okay, but you may tell me like this. Okay, well, here we have C, here we have C bar and AB. Why can't we use redundancy law? Well, if you use redundancy law, well, you can't actually use redundancy law. Why? Because the C has to be alone. C has to be alone. There is another signal here. So we can't use redundancy law here. Okay. And if you do the same thing with different pairs, okay, because instead of taking C, what if I had taken from these two, what if I had taken B? You may ask like that. Well, if you take B as a common factor, you will get A bar C plus A C bar plus A B bar C. Still no use. Okay. And you can take an A as a common factor for these two terms. Okay. You can take A as a term. But what will that give us? Well, that will give us B bar C plus BC bar. Again, dead end. So this specific question, okay, this specific expression actually has no simplification. So we can directly go for drawing the output. Okay, so here we have A bar BC. So let's draw the signal lines first. So we have A, we have B. So this is the logic circuit for this given truth table. Okay, it's pretty simple actually. There is nothing too hard here. Okay, you just have to know whether you should simplify further or not. Okay, so that's why we use another method. Okay, for simplification, without just using the Boolean laws, we use another method called K-map. Okay, kernel map. So this is what we will be learning in future videos after learning about max terms. Here we are using min terms. I'll teach you about max terms in the next video. So after that, we will be learning about K-maps. Okay, so stay tuned.
Thanks for watching the 18th video in our Logic 8 series. If you found this step-by-step guide to solving scenarios using truth table, min terms and circuit diagrams helpful, don't forget to like, share and subscribe for more lessons. Hit the bell icon to stay updated with our latest videos, check out the full playlist to master Logic 8 and follow us on Instagram. I will see you in the next video. Until then, keep learning and stay curious. Bye-bye.